Hello friends, and welcome to this class. In this class we're going to talk about a kind of triangle that we call the magic triangle. So we have different kinds of triangle, but there's this particular triangle that is very useful to us every single day. We call it the right angle triangle. The right angle. Okay, so the right angle triangle is a triangle in which one of the angles of the triangle is 90 degrees. Now, can you keep your elbows like this? This angle is 90 degrees. So, this is what the triangle looks like. 90 degrees. And remember that the sum of all the angles of a triangle is 180 degrees each. Therefore, if this is alpha and this is theta, that means, remember this is 90 degrees, that means the total sum of all the angles, which is theta, alpha plus theta plus 90, equal to 180 degrees. Therefore, for a right angle triangle, the sum of the two complementary angles is equal to 90, which is theta plus alpha plus theta equal to 180 degrees. Remember, it moves to this side 90 degrees, moves to this side and becomes negative 90 degrees. Therefore, the sum of the two complementary angles of a right angle triangle will give us 90 degrees. Okay, what are some of the important points about a right angle triangle? A right angle triangle is important because there are two rules that come to play when solving problems in right angle triangle. We have Pythagoras theorem and we have trigonometric ratios. Okay, so now these 2 points come into play when we are dealing with a right angle triangle. So the Pythagoras theorem states, assuming this side is A, this side is B, and this side is C, states that the square of this side plus the square of this side is equal to the square of this side. It has been proven and it has been tested and tried. That means A squared plus B squared equal to C squared. Trust me, this formula can be used to solve a host of problems. Then we have the trigonometric ratio. Have you heard of the word SOHCAHTOA? Yes. This represents the 3 main trigonometric ratio, which is sine, the sine of the angle. So we're going to take theta as our reference angle. The sine theta will be the opposite over the hypotenuse. C stands for cos theta equal to A for adjacent and H for hypotenuse. While T stands for tan theta equal to opposite over adjacent. So these are the 3 main trigonometric ratios and can be applied on a right angle triangle. Now let's talk about the sides of a right angle triangle. Now we have 3 types of sides in the right angle triangle. We have the opposite side, we have the adjacent side, and we have the hypotenuse. Now these three sides, the opposite stands for the side that faces the angle. The side that looks on the angle, while the adjacent side is the side that touches the angle. And the hypotenuse is the side that joins the opposite and the adjacent side. Note that these sides can change based on the angle that we are referencing. So if we are referencing theta, the opposite side will be, for theta, the opposite side of this triangle will be A, and the adjacent side, the adjacent side, that is the side touching the angle theta, will be B. Now if we're referencing this angle alpha, the opposite side for angle alpha is this. This side is facing or overlooks the angle alpha. So the opposite will be B, and the adjacent. The side that touches the angle alpha is A. So you see the way it changes depending on the angle that we are looking for. Then the hypotenuse is the same for both alpha and theta. And this is a summary of right angle triangle. Watch the next video for more examples of right angle triangle. Bye.